discussing periodic properties of element and chemical bonds. Basically, we will be splitting the discussion into different parts. Actually, today we will be discussing the part 1 section, which is from the beginning up to P block. In advanced master class, as you all know, we will be discussing, describing important informations from the extra writers. By extra writer in chemistry, we mean Kabir sir, Ghosh sir, and Lincoln sir. Among these three, most important book is Kabir sir, and that book carries some important information that are missing in Hazari sir's book. So I should say that I recommend that those who want to get admitted in the top medical colleges should please follow the class and take notes. So at the beginning, we see there is some information regarding periodic table. As we all know, there are 118 elements distributed in 7 periods, but on the basis of the elements present in the periods can be classified into different categories, such as the period which contain only 2 elements can be labeled as very short period. This one is very short, while the short period consists of 2 periods, which is second and third, because of carrying 8 electrons each. On the other hand, or similarly, I should say that long periods are 4th and 5th period because of 18 elements. And lastly, the very long or the longest periods are 6th and 7th because they have the highest amount of element that can a period have, which is 32. Anyway, the numbers are very important, and the numbers have separate or specific significance in terms of some other issues. These 2, 8, 8, 18, 18, 32. These numbers are called magic numbers. Why? Let me show you. If you know that these numbers serially, then it is easier for you to determine the atomic number of any atom that you want. Suppose you know the atomic number of the first member of the group, like group 18 starts with helium. You know that the helium atomic number is 2. So keeping that in mind, you can easily calculate all the other atomic numbers in that group. How? Let me show you. Add 8 with 2, you will get 10. Add 8 with 10, you will get 18. Similarly, adding 18, you will get 36. Adding 18, you will get 54. Adding 32, you will get 86. And lastly, adding 32, you will get 118. That's how. If you know the initial atomic number of a group, then you will be able to calculate all the remaining atomic numbers using this magic number. Okay. Moreover, there are some information regarding 57 to regarding the lanthanide and actinide series, which is 57 to 71 are included in the lanthanide series, and 89 to 103 are included in the actinide series. Lanthanide and actinide series atomic number are very important. Why? Because sometimes questions may appear like this. Determine the group and period of an element of atomic number 68. Then it would be difficult for you to formulate the electronic configuration of that atom because it is huge. On the other hand, if you can remember that it is in between 57 and 71, then it is easier for you to locate that atom in the periodic table because all of the members of the lanthanide series are located in the 6th period and group 3. Similarly, if someone asks you that an atom is 92 atomic number, so determine the group and period. So you see it is in between 89 to 103, so it will be placed in the 7th period and group 3. So from this discussion, we gain to know the magic numbers, and we have learned the range of atomic number between in lanthanide series and actinide series. Now, in our next slide, we see that the concept of elements according to some groups. Actually, we are leveling the groups according in various nomenclatures. We have already discussed that in some question solving sessions, but now I will remind you all regarding all the other names that we can call each group. In group 1, the name is alkali metals. Why? Because they react vigorously with water. They react vigorously with water to generate alkali. On the other hand, group 2 elements are called alkaline earth metals. Why? Because their metallic oxides and carbonates are found in the soil. That's why they are earth metal. And also they are alkali metals because they react with water, but less vigorously than the group 1. And regarding coinage metals, group 11 metals are called coinage metals, and out of 4 elements in the group 11, only 3 elements are labeled as coinage, which are copper, silver, gold. Similarly, group 1 contains 7 elements, but only 6 elements are labeled as alkali metals. And also we know that chalcogens are the elements which are found in ore or which generates ore. In the group 16, only 4 atoms are labeled as chalcogen metal, the initial 4, which is oxygen, sulfur, selenium, tellurium. This number is also crucial. Halogen, in Kabir sir book, there is a misinformation, which is halogen is 6 in number. Basically, halogen is 5 in number. Chlorine, chlorine, bromine, iodine, astatine. Tennessine is halogen according to Kabir sir, but it is actually not so. Remember that halogens are some elements which are found in sea salt, and we did not find tennessine in the sea salt. Yet, if there is any such option where only tennessine is the feasible answer in detecting the halogen, then we have no other options but to mark it as the correct one. Okay, now in the inert or noble gas section, one important title is to remember by everyone. This is called bridge element. Why these are labeled as bridge elements? Because they bridge between the non-metal and metals. Inert gas lie in a junction in between metals and non-metals. That's how they act as bridge. Everyone wants to get on the bridge by metals losing electrons and non-metals accepting those. So to gain that configuration, all atoms want to gain the structure of the stable inert gas. That's how the bridge concept again gets viable. Anyway, they're called rare gas, they're called inert gas, they're called noble gas, but nobody should say that it is ideal gas. Never ever. No ideal gas is there. Anyway, rare earth metals are actually lanthanide series. The 15 elements in the lanthanide series are called rare earth metals. On the other hand, very important classification is called metalloids. This has been appearing in the medical admission test for so long. How many metalloids are there? There are some confusion regarding that. Some writers say 6, some writers say 7, but the answer is quite simple, and do not go any further for any further doubts. This is 6, and the 6 metalloids can be easily recalled with a Bangla mnemonic, which is boro chele jeno আজ সব থেকে মাতাল। With boro we mean boron, chele we mean silicon, jeno we mean zinc, no we mean germanium, আজ arsenic, সব antimony, থেকে tellurium, and lastly this is basically metalloid. With matal we mean metalloid. So metalloids are 6 in number, and these are the 6 metalloids. Now pnictogen. Sometimes a family is labeled as a terrorist family because of one terrorist member. Similarly, group 15 elements are all not apneitic gases. Only nitrogen causes apnea. Yet, because of presence of nitrogen, all the group members are labeled as pnictogens. So pnictogen elements are group 15, and there are 5 elements in that, which is নদীতে পানি আসে সকালে বিকালে. That's how we can recall pnictogens. Okay. Now rogue elements. Rogue element basically hydrogen. Hydrogen is called rogue element because it is one atom that doesn't have a neutron, and it is placed within the group 1, which is a metallic group, though it is supposed to be along with the non-metals. Anyway, this is a rogue element. It didn't abide by the rule with that's why it is rogue. Ideal elements. Which are called ideal elements? Basically, ideal is a term that is reserved for those who follow rules, right? If anyone follows rule, he becomes ideal. Similarly, ideal elements follow the rules of periodic table. What are those? The Aufbau principle, Pauli's exclusion principle, Hund's rule. These are well worshipped by the ideal elements. And now, what are those ideal elements? Ideal elements can be labeled as second and third period because they only contain S and P block. So ideal elements have some other identities as well. It can be said that S and P block elements, it can be said that these are B subgroup elements, not B subgroup, rather A subgroup. B subgroup includes D block and F block. A subgroup includes S block and P block. A subgroup elements are ideal elements. Also, they are called representative elements. Representative elements. Okay, these are the titles that we should recall while marking the ideal elements. Noble metal, noble gas is inert gas, and noble are those which are very expensive, used in preparation or preparing the ornaments, which are gold, platinum, silver. Instead of copper, the platinum is placed. Copper is one of the worst metals because it is randomly used and found everywhere. Pseudo halogen. Now, this is something that is new to many of you. Pseudo means false. So it is not halogen, but it acts like halogen. And how do we find out or demarcate which one is pseudo halogen? A very easy trick is there. When you find pseudo as option, we should go for cyanide or isocyanide. I mean, you have to go for CN. If there is anything with CN, you will mark it as pseudo halogen. Okay? Pseudo halogen, cyanide, pseudo cyanide, pseudo cyanide. Repeat with me, pseudo cyanide. That's how you can easily mark the correct answer. Now, which pair is incorrect below? See, pseudo halogen cyanide, this one is correct. Noble element silver, this one is correct. Actually, noble element, it should be noble metal. Anyway, noble metal or noble element, whatever it is not wrong. Element of lower period. Phosphorus, coinage metal, mercury. Basically, this one is incorrect. This one is incorrect as well. Both of them are incorrect. Why? Because phosphorus is not in the lower period. Phosphorus is in the higher period. In fact, it is in the third period. So it is not in the lower period. Yet more wrong information is placed in the option D because mercury is not coinage metal. Coinage metal can be copper, silver, gold. Anyway, which one is both coinage and noble metal? Now it can be either gold or silver. So there is option A, option B, which is gold. Now regarding S block, solubility of S block salts are mentioned in Kobe sir book. See, calcium carbonate and bicarbonate. Though calcium carbonate is insoluble in water, but calcium bicarbonate is soluble in water. Regarding that, I have already discussed in the qualitative chemistry section. You should go to that masterclass, the part 2 part. There you will be able to recall all the solubility, insolubility matters in our chemistry book. But here I would like to remind you that if anything, if any compound, if there is bicarbonate, you should go for water solubility. Bicarbonate, ammonium, sodium, potassium, nitrates, all of these compounds are usually water soluble. Calcium halide. Calcium fluoride is insoluble in water, but calcium chloride is soluble in water. When the size of the anion gets bigger, then the solubility gets bigger. The solubility gets more. It does not happen according to Pajan's rule. According to Pajan's rule, it should be less soluble, but it is quite opposite. Yes. So next, we have seen that we see that alkaline metal compounds, group 1 compounds are soluble in water except 2, which are sodium pyroantimonate and potassium cobaltinitrite. These are the 2 compounds that are insoluble in water. All of the rest of the compounds of group 1 are water soluble. Now, there are some peculiar informations in Kobe sir's book which we may face in the admission test, but there is a good news that in the recent times, such questions did not appear in the admission test. But there is a but. What should we learn at least for medical admission test? Let me mark that for you. First of all, you have to know borax. You have to know what is gypsum. You have to know what is dolomite. Dolomite is mentioned in several chapters of our book. And also here you have to know about carnallite. You have to know for soda ash. Okay, these are the supreme important one. These are the supreme important. Now, if I mark less important ones, a bit less important yet important, then I would say chili, saltpeter, niter, chrysoberyl, emery. Okay, these are and also pearl ash. These are the second most important. So first go for the green ones, next go for the yellow ones or the orange ones. Here, there is no such technique to memorize this information. There are no mnemonics. You cannot remember the formulas with mnemonics. You have to figure it out yourself. One more thing I should add, that gypsum, the formula of gypsum is calcium sulfate dot 2H2O. Once it is calcium sulfate 2 molecule, but water is 1 molecule, then this is called plaster of Paris. What it is called? Plaster of Paris, that is used to immobilize the fractured structures of our body. General properties of S block metal elements. S block, I recall the properties of S block like this. S, soft. This is so soft that it can be cut with knives. So it should be of lower density, less weight, low boiling point, low melting point, but the metallic property should be high. That's how I recall all the property of S block. Now, see here, S block elements and P block elements are called ideal or representative elements. And there are 8 elements in the fourth period in the periodic table, which are called ideal elements. 8 elements of the fourth periodic table, from potassium, calcium, from gallium to kryptonite, are called ideal elements. These are mentioned in Gosar book. Group 1 and group 2 elements include total 14 elements. 14 elements. 7 from the group 1, 6 from the group 2, and 1 within. So basically, 7. Why? Which element is placed? Actually, which are S block element? Group 1, group 2, and group 18. Group 18, we have one member from group 18, which is helium. Group 1 contains 7 elements, group 2 contains 6 elements, 7 and 6, 13, and the remaining element is placed in the group 18. Yet it is included in the S block because the last electron goes to S subshell. Group 1 elements are called alkali metals, and alkali metals, as their oxides and hydroxides, are strong alkali. These, I have already mentioned this. And group 2 are called alkaline earth metals because oxides and hydroxides are alkaline, as well as they are found in the soil. Okay. Now there are some exceptional behavior of lithium. Lithium is a very small metal, very small. See, because of a smaller size, it shows higher polarization power, and also it has no d orbital in its valence shell. That's why it shows higher ionization potential and higher hydration energy. So most of the compounds of lithium are covalent in nature because of the high polarization. These are the reason behind the exceptional behavior of lithium. Now, use of group 2 metals at a glance, we should know that to increase the strength of bond, we have to eat calcium-related compounds. Also, for transparent medium of X-ray, though it is mentioned as beryllium, but basically we use barium. Okay, but if it is written in your book as beryllium, we have to mark it. But the correct answer should be barium. Easy source of alpha and gamma ray is any radioactive source, and one of the most common radioactive source, Madam Curie, who died discovering or handling with this source, which is radium. 60% of our bone is phosphorite, which is calcium phosphate. Now, regarding the melting point and the first ionization potential, I should say that do not remember or memorize all this information. I only mark those which are very important. For lithium, the melting point is 180.5. This is crucial, and the ionization potential is 520. If you can remember this, that is enough. But let me show you one thing, that in a group, the melting point gets decreased from top to bottom. This does not happen for all the group. In case of group 17, we find the opposite. We can see that fluorine is a gas, but iodine is a solid one. But here we see lithium is a solid, but cesium is a liquid at room temperature. By room temperature, I mean the actual room temperature, not the 25 degrees Celsius bookish one, because currently room temperature is never 25. It is only 25 if you apply air conditioning. Anyway, I should say that cesium is a fluid metal. If there is an option as cesium, which one is a liquid metal? If there is the only viable option is cesium, then the cesium can be marked. Moreover, francium, gallium, and mercury are known as liquid metal. But among all these four, the well-celebrated liquid metal is mercury. Okay, now next, the characteristics of the alkaline earth metal. Regarding that, you can only remember the ionization potential of beryllium. You should know that beryllium does not have any ionic compound. Beryllium only forms covalent compound because of high charge and less size. Okay, which is not true for potassium. Potassium is an ideal element. This is true. This is highly electropositive. This is gray color, low ionization potential. So which is not true for potassium? See, potassium is not gray color. It is of blue color. That's why this is not correct. Okay, this should be what? This should be blue. Lithium shows exceptional behavior despite being a metal because of very small size, high polarization power, higher ionization potential. Certainly, all of them are correct. Which one has the lowest ionization potential? The lowest ionization potential should be shown by the one at the bottom. Birani, Moglai, Kabab, Shoria. With this mnemonic, we remember the group 2 members, and among them, barium should show the lowest ionization potential. We know from in the periodic trend, we see that ionization potential gets increased from left to right and decreased from top to bottom. Now, some different concepts we have already discussed, which is ideal or representative elements. What are called halogens? See, sodium fluoride is not possible. Again, inert gas, chalcogens, metalloids, these are already discussed, so we should not waste any further time here. Now, regarding group 13, some important information are placed in Kobirsar book, such as group 13 is a mixture of metalloids and metal. One metalloid is boron, and the remaining metals are aluminium, gallium, indium, thallium, and nihonium. These have among them boron shows higher melting point, which is 2330. Regarding the source, let me mark it. You should know about corundum, you should know about bauxite, and most importantly, kaolin. This formula has already appeared in the medical admission test, which is aluminum oxide, 2 silicon dioxide, and 2 moles of water. Okay, aluminum is extracted from the molten process of bauxite. Regarding oxidation state, you see electronic configuration of their outermost shell is NS2NP1, so the oxidation number is +3. And nature of the elements. Regarding that, we know aluminum oxide is amphoteric. Aluminum chloride is a bit sublime agent. It forms a dimer, and the dimer gets sublimed. I mean, it becomes gas from solid at 180 degrees Celsius temperature. That is important. This temperature is important. And these metallic compounds are mainly ionic, although aluminum chloride, aluminum bromide, and aluminum iodide are covalent compounds. Aqueous solution of air salt is acidic because because of the weaker base nature of the aluminum one, and the anions came from the strong acids. Now, inorganic graphite. This is a crucial information that may appear in your questions, so be very careful regarding that. Inorganic graphite is boron nitride. Boron nitride. Somewhere it is written as Bn, somewhere it is written as Bn3. Whatever you find in the question, mark it as the inorganic graphite. Okay, and the bond angle, bond length. The bond length of carbon-carbon is 0.142, while the bond length of Pn are 0.145. That similarity is responsible for calling it as inorganic graphite. Now, regarding group 14 elements, are non-metal, metalloid, and metal combination. So you can identify what are the identities of the different members. Now, melting point. These are very important information. Melting point of dry ice is -56 degree. Melting point of silicon dioxide is 1610, and boiling point is 2230 degree. Main source of carbon is coal. These are very important information. Source of silicon is sand and quartz. This is also important. Source of silicon is sand and quartz. And lastly, source of lead, galena. Galena is a very important ore, which is lead sulfide. Regarding oxidation state, you should know that most of the oxidation state ranges between 2 and +4. But for lead, except lead, for other elements, +2 oxidation number is unstable. This is an important exceptional information regarding 14. In case of some other informations are there, like carbon and silicons are non-metals, and also all compounds of stannum are covalent. All compounds of stannum are covalent. Basically, it is not that important. This is not important. Octet expansion is possible in case of silicon. This is also known to us because it has vacant d orbital. Regarding catenation, we know the property or ability to generate chains within the same molecule along in between two same atoms is called catenation. So catenation property is a unique property of carbon. Also, silicon can form catena, but the bond energy is very less. That's why the catena gets disrupted. Compared to the silicon oxide bond, it is less stable. That's why silicon oxide forms the chain and creates a giant polymer. Allotropism. Silicon has 3 allotropes. These are alpha, beta, and gamma. And carbon has some allotropes, which are diamond, graphite, fullerenes. At 1000 degrees Celsius, this is very crucial information. At 1000 degrees Celsius temperature, diamond gets converted into graphite. So if you heat any diamond at extent, it can easily be converted into graphite. I think we should not do that because diamonds are much more valuable than graphite. Comparison between diamond and graphite, we have to learn it from the Kobe Sir's book. This is very, very important. VBI for medical admission test. We know the hybridization difference. That is the reason behind the electroconductivity of graphite. Graphite can conduct electricity because one electron is there to roam around the different sheets, different layers. That's why it becomes electrical conductor. And you know, regarding electrolytic cell, we use the graphite electrode as the electrode. Graphite rod is electrode. The structure is very important. Tetrahedral and hexagonal, and the bond length 0.154. Here it is 0.142, and the bilayer distance is 0.335. Melting point is sometimes unbelievable. Why? Because we know graphites are weaker than diamond. Yet the boiling point is more for graphite, 3730 degrees Celsius, while diamond shows 360 degree, 3600 degrees Celsius as melting point, not boiling point, melting point. Diamond can conduct heat, but cannot conduct electricity. But graphite can conduct both heat and electricity. Now, regarding silicon, some information are there, such as silicon is the main component of computer chip, which shows 1.9 electronegativity, and oxides are acidic. Again, the name of silicon came from the Latin word silex. Who proposed this name? Thomson named it, and it was discovered by Berzelius. Silicon was discovered by Berzelius. 28% of Earth's surface is made of silicon, one of the world's 8th most abundant element. You may be wondering which one is the most abundant element in Earth. The answer would be oxygen. Oxygen is the most abundant element. It is present in the atmosphere, it is present in the water, it is present in the pores. The 20th and 21st century period is called the digital age, or the information age, or silicon age, because of its exclusive role in digital or information technology. Without silicon, it would not be possible. It would not have been possible for you to enjoy this class too. So let's take a moment to thank silicon. The crystal frame of silicon is side concentric cube. Now, regarding kaolin, the formula is very important. Portland cement, this is also important. It is a combination of tricalcium silicate, dicalcium silicate, and tricalcium aluminate. Okay. Regarding the glass, this is the soda glass, which is soft glass, where sodium oxide is present along with calcium and calcium silicate. Ceramic or porcelain, the formula is important here. Aluminum silicate is added with cristobalite from the porcelain. Zeolite, basically it is used for the ion exchange process to remove the permanent hardness of water. Zeolite is used to remove permanent hardness of water. The formula of carbon atom is important. Silicon carbide, it is one of the most rigid structure. Now, regarding the nitrogens, we have already mentioned why they are called nitrogen, because they are suffocating gas. All of them are not suffocating. Nitrogen is a suffocating gas. Now, regarding the words, largest source of nitrogen should be air, and main source of phosphorus are 2. 60% found in bone, and we do not extract phosphorus from bone. Different words like phosphorides are also present. Oxidation state can be ranged from -3 to +5. Now, regarding the oxides of nitrogen, this is very important. VBI. Nitrogen shows 5 oxidation state and 5 oxides, which are nitrous oxide, also known as laughing gas, nitric oxide, which helps to dilate vessels, dinitrogen trioxide, this one is a acidic oxide, dinitrogen tetroxide, this one is also an acidic oxide, and lastly dinitrogen pentoxide, this is also an acidic oxide. Regarding the first two, these are not acidic, these are neutral oxides. Nitrogen dioxide, nitric oxide and nitrous oxide are neutral oxide, and the remaining ones are acidic. The dinitrogen trioxide, when reacts with water, generates nitrous acid. That's why it is called nitrous anhydride. Again, the dinitrogen tetroxide, or simply nitrogen dioxide, generates nitric acid when reacts with water. That's why it is called nitric anhydride. Basically, it is not nitric anhydride. It generates both nitrous and nitric. That's why it is called mixed anhydride. Nitric anhydride is the identity of dinitrogen pentoxide. When it reacts with water, it generates nitric acid. And this one is mixed anhydride. Okay, allotropism. All elements of this group have allotropes except this one. This is the important information. Regarding the structure, molecular structure of nitrogen is linear, while the white phosphorus structure is tetrahedral. That's why it is called P4. Now, regarding the halide formation, some statements are there, and these are very, very important for MCQ. See, nitrogen can form nitrogen trichloride, but cannot form nitrogen pentachloride because nitrogen cannot accommodate those electrons because of absence of D shell. Nitrogen trifluoride is quite stable, but all the halides are somewhat explosive because all of them can expand their octet. Sorry. Now, phosphorus can form PCl5 when activated. It is called octet expansion, but phosphorus iodide cannot become phosphorus pentiodide because of its larger structure. Except NF3, since it is stable, it should not react with water. Ammonia acts as alkali, reducing agent and ligand. These are very basic information. I think you all know about it. Now, regarding hydride formation, we know ammonia shows more alkalinity than phosphine. Why? Because nitrogen shows higher electronegativity and lower size or smaller size. That's why it tends to donate the electron more easily or more readily than the phosphorus. That's why it becomes stronger base. And some examples of hydride. Ammonia is NH3, but what is N3H? It is hydrozoic acid. Just notice it. Regarding the interconversion of white and red phosphorus, it used to appear in the medical admission test invariably. I mean, if it is not in this year, then it will be appeared in the next year. Such importance was there for this question. But regarding considering the current question pattern, we did not find such information. But you may want sometimes questions can directly come from the question bank. For that, you have to remember this. White phosphorus can be converted into red phosphorus, and it only takes only 250 degrees Celsius temperature. On the other hand, to become white phosphorus, you have to use 550 degrees Celsius temperature. I easily remember that. Suppose it is a parlor, you have to become white from red. It is expensive. That's why you have to spend 550 taka. On the other hand, making red is easier. If you box someone, her or his face can become red. So it is easy. That's why only 250 taka discount. Okay. Anyway, that's what I used to remember this information. You may use your own technique. Now, regarding allotropism of 15 elements at a glance, we see that antimonies have metallic, alpha, and explosive. Here, important one is arsenic. Gray, yellow, black. Gray, yellow, black. Regarding phosphorus, we have white, red, black. White phosphorus is P4, red is P8, and black is unknown to us. Alpha and beta nitrogen. Alpha is cubic, beta is hexagonal. This is also important regarding nitrogen. Now, for group 16 elements, we know all of them are not chalcogens. Only the first 4 elements are chalcogens. Tellurium is a metalloid. These are electronegative. And regarding the source, you should know about galena and nothing else. Cinnabar, mercuric sulfide is also important. Orpiment, which is arsenic sulfide, this is also important. Oxidation state, we know that oxidation number of oxygen is -2, but in case of peroxide, it is -1. In case of superoxide, it is -1. This is very, very important. Regarding allotropism, we know oxygen has 2 allotrope, which is oxygen and ozone. These are the 2 different molecules that oxygen can form. Moreover, sulfur, rhombic sulfur shows an S8 molecule, so it looks like a puckered ring, and also sometimes it looks like a crown. So which molecule looks like a crown? If it is in the question, you should mark S8 as answer. Regarding allotropism of sulfur, there are 3 types of allotropism: granular, agranular, and liquid. Regarding granular, there are rhombic and monoclinic, agranular, plastic and white, and liquid, lambda and mu. There is a Bangla mnemonic to remember all this. You know, granular means Danadar, agranular means Odanadar, and liquid means Torul. So using these 3 Bangla letters, we can say Damra, Apod, Tomal. Now let's match it. For Mo, we get monoclinic. For Ra, we get rhombic. These are granular. For Odanadar, Po, plastic, Do, white, Dugdho, Ba, white. For Mo, we get mu. For Lo, we get lambda. That's how we can easily recall all the different types of allotropes of sulfur. This is again very, very important. See, this is very, 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 very important. You cannot go to admission test without remembering this chart. This is the final message. Even we have already discussed it in our regular masterclass. You have to know which are acidic oxides. Acidic oxides are non-metallic oxides. You have to know which is basic oxides, which are metallic oxides. There are some neutral oxides. Neutral oxides can be recalled using a mnemonic: Kono, Kono, Pani, Nai. With Ko, carbon monoxide. No, nitric oxide. Pani, water. Nai, nitrous oxide. Regarding amphoteric oxide, there is a mnemonic in your Minitrix. Please go to your Minitrix and use that mnemonic, which is Johnny Tumi Aaj India Gele Shona Pabi Pabe Bollam. With that, you can recall all the oxides, including the Kovir Sir book. There are some other oxides as well in your Hazari Sir book. You have a complete mnemonic in Minitrix. Go find that mnemonic in Minitrix and remember that. Regarding peroxide, the oxidation number is -1. Regarding the superoxide, the oxidation number should be +half. -half, right? Minus or plus? Let's see. Superoxide minus half, peroxide minus 1. See, minus half. Polyoxide means there are more oxygen than it's supposed to be. We can recall that with polyet mon pabe. Seems like a Bangla cinema name, but yet it is effective. Polyet mon pabe. Mon, manganese oxide, pabe, lead oxide. Okay, these are the polyoxides. Lead suboxide is also there, which is Pb2O. And there are some mixed oxide. You have to know the components that are mixed to get these oxides. Regarding the sulfur compounds, there are some compounds which have multiple property. Like sulfur dioxide, it is one acidic, it can act as oxidant, it can act as reductant, it can also act as a bleaching agent. Regarding hydrogen sulfide, there is acidic nature, reducing nature, and also it can be used as precipitating reagent. Regarding hydrogen sulfuric acid, as the oxidation state of sulfur is the maximum here, that's why it will not act as a reductant, it will act as an oxidant only. That's why it can also act as a dehydrating agent. These are the identities that are very important for medical admission test. Now, regarding the group 17 elements, which are also known as halogen, we know first five elements are called halogens. Not all the 6 elements are halogens. Who proposed the name halogen? The scientist named Berzelius, who discovered silicon. Regarding source, we have to know about brine, we have to know about kelp. That's it. Nothing else is required from this. So, regarding the physical and chemical properties of group 17 element, you should recall the colors. Chlorine is light yellow, chlorine is greenish yellow, while bromine is a red liquid, and iodine is a violet solid. Electronegativity should be remembered for all the halogens, serially, 4, 3, 2, something like that. Value of electron affinity is high, but the highest electron affinity among the halogen is shown by what? Chlorine, not fluorine. Fluorine shows higher electron affinity than fluorine. Overall, these are highly reactive nonmetals. The most reactive are halogens. Except fluorine, all halogens can show variable oxidation state. Okay, and fluorine's oxidation number is fixed, which is -1. Halogens are strong oxidizing agent. Fluorine is also a bleaching agent. It bleaches with the process of oxidation. Okay, and just as halogen is the most active nonmetallic element in the periodic table, they also combine with another to form interhalogen compounds. Okay. Regarding the acidic property and bleaching action, we know that chlorine reacts with sodium hydroxide to generate, this is basically disproportionation reaction. Since the oxidation state here is 0, but here it is -1, here it is +1. Both oxidation and reduction takes place for single atom in a single reaction. This is called disproportionate reaction. Proportionation reaction. The opposite of disproportionation reaction should be comproportionation reaction. And here, as we can see, this is the bleaching powder. This bleaching powder acts by oxidation. It generates the nascent oxygen that is responsible for bleaching. HF is the weakest, we all know. Regarding the hydroxides, as the anionic size gets increased, the strength of the acid gets increased. And we know the highest amount of acidity is shown by hydrogen iodide. Disproportionation reaction means single oxidation state would result into different oxidation states. One would be positive, one would be negative. So simultaneous oxidation and reduction for a single atom is called disproportionation reaction. Okay. There are the examples. Some exceptional facts regarding halogen. You should know that with decrease in atomic number, the value of bond dissociation enthalpy gradually increases. Bond dissociation enthalpy gradually increases from iodide towards chlorine. Also, hydrogen chloride forms hydrogen bond, but rest of the halides do not participate in hydrogen bonding. Fluorine is not produced by oxidizing metallic fluoride because fluorine is the strongest oxidizing agent. Such informations should be learned with optimum care. Now, regarding the order of properties of group 17 elements, this is very easy. Strength of hydroxide has come in different admission tests. Moreover, van der Waals attraction force is the responsible factor because of which the melting point of halogens gets increased from top to bottom, because the van der Waals force is most for the larger size, which is iodine. Regarding the electron affinity, we know fluorine comes after chlorine, and rest of the options are very similar. Now, regarding the use of chlorine compound, we know that freons or refrigerants contain chlorine, and it is used in refrigerator and air cooler. Also, Dettol have chlorine, which can be used as disinfectant and antiseptic. Dettol is also known as chloroxylenol. Now, regarding bleaching powder, the formula should be remembered by all. DDT, gamoxine, dieldrin, these are insecticides that contain halogen. Moreover, polyvinyl chloride, which is a well-known polymer to us, the monomer contain vinyl chloride, which contains chlorine. Carbon tetrachloride acts as a fire extinguisher, but nowadays, instead of carbon tetrachloride, bromochlorofluoromethane is used, which is known as PCF. And Vestrosol is a dry cleaning liquid, which is used in dry cleaning. So Vestrosol, Vestron, these are some informations you may find in organic chemistry, and you should remember those, because these are very puzzling. In admission test, if you don't know, you will get puzzled with these informations. Anyway, regarding different names, also we know group 18 we have already learned that these are called inert gas, noble gas, or rare gas. Elements are also known to us. And regarding physical and chemical property, all of them are testless or LS. They do not tend to participate in any kind of reaction. Even if they do, only argons are very eager to form bonds, and argon shows the highest number of bonds, right? Argon or krypton. Okay, these are the informations that you require. The ionization potential is extremely high. Why would not that be? Because it is in the rightmost corner of the periodic table. Since they have no tendency to combine, their valency is 0. Regarding helium, some information is there. These are also found in your Hajarisar book. What is the lifting capacity of helium, which is 92. You should know that in NMR machine, liquid helium is used, and also oxygen-helium mixture is used in the treatment of asthma. The melting of more reactive metal is done in the presence of helium gas. Helium is used to reach absolute zero temperature. Regarding the neon, you should know that neon tube lights are used in the operation room, and also it is used for light in airplane. Argon is the most abundant noble gas in air, which is 0.93%. And regarding krypton, you should know that in tube light krypton is used. In normal light, argon is used, but in tube light, krypton gas is used. Also, it is also used in case of miners. Moreover, photographic flash bulb contain krypton. Okay. there is an information regarding neon which is used in voltmeter. Green or blue light is also, yes, this is the voltmeter, not voltmeter. Voltmeters and commercial neon lamp, we use neon. So these uses of inert gas is very, very important. Very, very important. Try to take notes from this. Now at the last slide, as we can see the allotropic conversions of the sulfur, effect of temperature on sulfur. We do not have to remember all this. Just know that to convert rhombic to monoclinic, we only need 95.5 degrees Celsius. With that, I think you have to, what you need to know is within these two. No more information is required from this lengthy flowchart. So our discussion came to an end, but it is incomplete if you do not practice the questions from the exercise. So go jump to our question bank and find all the questions from extra writers and try to solve it at your own after this class. Thank you. Best of luck.